So I've talked a lot about whittling it down, and here I just want to go through an example of exactly what I mean. So we need to know what are our possible zeros. Now if we go through the factors of the numerator and do our possible zeros test, we've got 1, 2, 3, and 6. That's from our constant. And then on the bottom we've got just a 1 because x to the fourth has just a 1 in front of it. So 1, 2, 3, and 6 are really the only ones that I can try a positive and negative. Now, let's say I don't do any whittling, and I'll show you what I mean. Let's say I try, I'm going to cheat a little bit here just because I know the answer and I want to get my point across here. So I try -1. So I put down my coefficients, and a 1 drops down, gives me -1, -2, 3. What does that give me? -3, -6, +6, I get my 0. So -1 is a 0. Now let me try another one too, and I'm going to go ahead and I'm going to use the coefficients from the original again. So this is not whittling, this is just using the originals again. So I try 2, and I've got 1, 2 times 1 is 2, 1, 2, 3, 6, 3, 6, 0. Hey, 2 works also. So I've got 2 of my zeros, -1 and 2, and I need 4 of them. So right now I know that -1 and 2 work, but the only other choice I have is to try all these other ones here. There's no clue within this work here what else is going to be a 0, and that's a problem because I have 4 to find and I've only found 2 of them. And how do I know if -1 worked again? See, if I use -1 and use these numbers again, of course it's going to work. It worked the first time. Why wouldn't it work the second time? So I need to know, is -1 going to have a multiplicity more than 1? Or is 2 going to have a multiplicity more than 1? Or is there something else? And so what we do is we whittle it down. So let me show you what I mean. So let's do that -1 again. Okay, so I take -1 and put it in the box, and I get 1, -1, 1, -3. So here's my coefficients. Okay, I go through the work. All right, and I got 0. Now, I know that -1 works. That's great. Now, what I'm going to do is I'm going to use 2, but now my 2 I'm going to use right here in the box. See, what happened when I got that -1 is I took that original problem, and this was the original problem, plus x minus 3x, oh, that was a squared. I can't do this and talk at the same time. And by finding -1 was a 0, I found that x plus 1 is a factor then. And if x plus 1 is a factor, it would be multiplied times what I had gotten. So I'd gotten x cubed minus 2x squared plus 3x minus 6. See, that comes from this answer right here. I put them into the polynomial form instead of just the coefficients. So these two are multiplied together to give me this. So now I'm saying, what else can I get out of this? What zeros can I get out of here? Because whatever zeros are here are zeros of this plus that one. So I'm taking this, using the coefficients, minus the 0, ignore the 0, and I'm using that 2 now, and I'm whittling it down from those. And oh, look at that, I got a 0 again. And so then if I look, now I factored it into x plus 1, and then I have now an x minus 2 from what I just did, and then I have left x squared plus 3 left. That's what I get there. And so now look at, I've got an x squared problem, and I can use a quadratic formula. I can use the complete the square. And this one you would actually have to go through the quadratic formula because what's happening is you're going to have something else. You're not going to have any of those numbers from the possible zeros that we were looking at. Okay? So this is where whittling down comes in, and I suggest you do on every single problem, is that you use that answer you got from your 0 to find the rest of your zeros. And if this wasn't squared, then I would use this to find even more zeros. But once I get down to a squared problem, then I can actually use that and do the quadratic formula or something like that, or double bubble even. So that's whittling it down.